Good morning everyone. So today we'll start talking about descriptive statistics. So the first thing we should talk about is univariate data. So what we're going to discuss here is related to a single variable. So let's say for example that you're a waiter at a restaurant, and every waiter at this restaurant gets tips. And then you assess, you and your colleagues, you assess after each week how much money you have. So you're basically investigating a variation of something, but it's just one variable, isn't it? The only variable that's changing there is your money. How is it changing with time? Now, there's also two main types of variables. So we've got qualitative data and quantitative data. So when you're talking about things in which you cannot describe them as numbers, or they might be subjective, then you've got some qualitative data. So for example, if you're talking about some preference, your favorite ice cream flavor, this would be qualitative. It's not quantitative. It's not something you can measure, right? Most of the time in maths, we'll be dealing with quantitative data. That's what matters to us. That's what we can count. Now, quantitative data is divided into discrete and continuous. Now, discrete is basically what you can count. 1, 2, 3. Continuous usually is what you can measure. So your height, your weight, and things like that. So let's take a look at a very quick example here. So we've got the number of cherries in 24 boxes shown below. So we've got numbers here. You can see that all of them you're basically counting, right? And there's no half a cherry. So this is discrete data, right? You're basically 1, 2, 3, 4. There's no 1.5 and such. Now complete the frequency table below for this data. So how many times do we have 42? How many times do we have 41? So we have to count. 1, 2, 3, 4. Right? And we can fill this table. So 42, 1, 2, 3, 4, 5, 6. 43, 1, 2, 3, 4, 5, 6, 7. 44, 1, 2, and 45, 1, 2, 3. It's done, right? Now you could also have some cumulative frequency, right? So cumulative frequency, you're taking into account everything up to that number. Do you remember that? So for example here, up to 40, you've got 2. Up to 41, you have to add what you had up to 40 plus what you have now up to 41. So 2 plus 4 here is 6. So basically, that's why it's cumulative frequency. You're summing up everything up to that point. So here 6, with 6, 12, and then with 7, 19, with 2, 21, and with 3, 24. And if you plot this graph, you would have a curve that you're probably used to, in which this is 100%, right? Oops. Something like that. That's kind of revision, isn't it? Now, here we have some example, which is continuous. When we're dealing with continuous variables, we'll have ranges instead of numbers. So in the previous example, we had how many times did we find 40 cherries, 41 cherries, 42 cherries. Well, now since we may have numbers in between, we need to have ranges. So here it's length in time, time in minutes, right, from 0 to 5. So here from 5 to 10, 10 to 15, right? So 4.2 would be in this interval here. 6.8 would be in this one, and so forth. So we could fill this table. Now you can pause and try it yourself. Alright, so let's do it. Up to 5. So we've got 1, 2, 3, 4, 5, 6. Now from 5 to 10, so we just have to check. We have crossed everything up to 5. So now everything, we just check everything up to 10, which is still there. So 1, 2, 3, 4, 5, 6. 6 again. Now 10 to 15. 1, 2, 3, 4, 5, 6. 15 to 20. 0. Nothing. And 20 to 25, 2. And that's our frequency table. If we had our cumulative frequency as well, what would we have? So 6, now up to here 12, up to here 18, up to here still 18, and up to here 20. And, well, obviously this number has to match with this one because that's the total number of occurrences. Now it's also important to remember, you've seen this before on your ICCs. When you plot those graphs, if you plot some histograms for instance, since this is continuous data, your columns, they would be touching, right? This is when your data is continuous. When your data is discrete, you will have gaps between your different sets, your different numbers, right? For example, in the previous example, this would be 40, this would be 41, 42, and here those mean intervals. So here 0, 5, 10, 15. Now obviously those heights, they do not represent this problem. It's just an example of how a histogram would differ. Just remember that when your data is discrete, there will be those spaces between data here. So this is the last example we're going to cover. We've got the ages of boys in a football club and all of those numbers. Now letter A, state whether this data is discrete or continuous. Well, it's age, right? Even though we're just writing 10, 11, 10, 12, this is actually 10.0, right? Another one could be 10.2, but we just assume that 10.2 is 10. We call it, if you're like 10 years and a half, well, we won't just say half. Nobody says that. You just say, I'm 10. I'm 10 years old. You don't say I'm 10 and a half. You might. It's not wrong. But people don't. If you're 10.5, you're 10. When you reach 11, then you're 11. Right? So this data is actually continuous. Do not base yourself, oh, those numbers, they are whole numbers, therefore it's discrete. Also, another thing is, how do you find out the age? You have to measure somehow, right? You're measuring time, but you're measuring. So it's continuous. Now B, construct a grouped frequency table for this data. That's the kind of table that we have been dealing with in the previous couple examples. So what we're going to do, well, age and frequency. So ages, they start at 10. So 10, oh, since it's continuous, we'll have ranges. So equal to 10 and less than 11. Alright, and I'll fill this in really quickly. So those are the ranges that we have from 10 to 11, 11 to 12, and so forth. And now what you would have to do is just count them, just like we did before. So from 10 to 11, well, from 10 to 11, everyone's going to be registered as 10, because if you are 10, if you're, let's say, 10 years old, 11 months and 30 days, you're still 10. So if we count those, 1, 2, 3, 4, 5, 6, 7, so that would be 7. Now you can pause and find those yourself. I'll just fill the table in so you can check. 9, 7, 3, 4, 5, and 5. So if you count those, you should find those numbers. So this is what we call a grouped frequency table for the data. And that's it.